Good morning, Preeti. I was just trying to tell you if you have your NCERT books, I can quickly help you see through those. So we were doing geological time scale. I hope you remember those eons. Eons are the largest ones. Then we have era. Okay, the eras are subdivided into periods. The periods are subdivided into epochs, and epochs are divided into age. So I said, याद करने के लिए, I think most of us would know. Most of us would know eons, and this I said, remember EPEA. Okay, this was one of the questions asked in the previous years, and eons. People make a mistake. The board not responding. Okay, so we talk about eons. Eons. Remember, eons are Phanerozoic eon. We also have Proterozoic eon. We have the Archean or Archaeozoic, and we have the Hadean. So a lot of people make a mistake of seeing these as part of the era. ये part of era नहीं है. These are part of the eons. So in your differentiation, I said, if you have eons here and you have drawn the eras here, if you write eras here, so era is Paleozoic, Mesozoic, Cenozoic, and these three are part of Phanerozoic, and these are those Proterozoic, Archean, and Hadean. Okay, so your era idhar aayega. So don't put this on this side. Lot of books write this completely like this, doesn't matter. Okay, but you remember that Proterozoic is part of eons. This is one thing I focused on. Then I gave an approximate idea about the times, 550 million years, 240 million years, 60 million years. We talked about 1.5 million years, boundary between the Pleistocene and the Holocene. And Holocene, we said 11,700 or 12,000 years. So I think you understand the divisions here. We have the tertiary times, the quaternary times. In दोनों के बीच में 2 million years, 2.5 million years, and the division here. I spent some more time discussing Holocene. We divided Holocene into 3 blocks: the Greenlandian, the North Gripen, and Meghalayan. And I talked a bit more about the Meghalayan age. Starts around 4,200 years before present, a time when we had droughts, dry conditions. It impacted civilizations. It was based on some discoveries we had in Meghalaya Plateau. Okay, and then I gave you the list of some important development across the different times. When did we have the first land? When did we have the first atmosphere? When did we have the oceans? The first life forms, the insects, the reptiles, the evolution of fold mountains, Pangea creation, the ice age. Okay, this was the discussion in your textbook. If you have this book with you, so it mentions some of the important ones. So my recommendation is that you have an idea about Archean times having blue green algae. I mentioned cyanobacteria. ये भी add कर देना फिर. The blue green algae evolution in the Archean times. Then we talked about how the Paleozoic had invertebrates, it had fishes. We talked about the coal beds of Carboniferous times and the reptiles. Okay, the Paleozoic में ये life forms हैं. Then Mesozoic times, the age of dinosaurs, extinction of dinosaurs. Dinosaurs had begun evolving from the Triassic times. Okay, and then they go extinct in the Cretaceous times. Okay, and the rest. Okay, so this was the discussion we had. Then we moved on towards discussing minerals. We defined what minerals are. In fact, I would like you to check up your textbook again on this. Tomorrow onwards, keep the textbook handy. I'm not saying कि सारा कुछ इससे पढ़ना होगा, but keep it handy. You can refer quickly as and when I tell you. I'll just show you the page here. Yeah, page number 40. Chapter 5 देखो, if you're having the book with you. Chapter 5. Look at the first column, you have the box. Okay, it says, mineral is, and I gave you these points. Minerals are, because यही में फंस हो गया. Minerals are natural, I said. Minerals are inorganic. Minerals are mostly compounds. And we said minerals are crystalline. These are the 4 important properties of minerals. वो box में देखो, it says, thus a mineral is naturally occurring organic and inorganic substance. So I have mentioned inorganic. You keep it as inorganic, but अगर choice में organic आया, उसको wrong मत कर देना. Because NCERT says so, that's simple. If I go by the technical definitions, minerals are inorganic. NCERT mentions organic. Okay, so just know this. Okay, that some minerals can come, but actually galat hai. But NCERT says so, we take it up. Okay, so inorganic and organic, it has orderly atomic structure, matlab crystalline hai. Definite chemical composition and physical properties, because the compounds, they will have definite properties. Properties, both physical and chemical. And then sometimes they are also elements. So sulfur, copper, silver, gold, graphite are also elements. So in your notebook, you could add example. I have mentioned gold, you can mention the other examples also. Sulfur, copper, silver. कौन सा chapter? Chapter number 5. I told all of you yesterday, please bring your fundamentals of physical geography. Okay, you will be surprised how much of content this book has. Okay, and every time I read the book, after all these years, I still find something that I have been missing. Okay, so page 40, I said, page 40, कम से कम notes में लिख लो, go back home and check at your convenience, page 40, and I said, write down the other examples of minerals which are elements, not compounds. So it says sulfur, copper, silver, gold, graphite, etc. are also element minerals. They are also element minerals. In fact, page 41, if you look at the first column last, metallic minerals. Okay, the following are metal content. They say it's gold, silver, platinum, and so on. You can also add platinum for that matter. Okay, the examples of minerals which are element form. Okay, yesterday I didn't mention this. I should have done it. How are minerals differentiated? Differentiated. What are the important properties What are the important properties for studying minerals? When you study minerals, what are the properties you focus on? Okay, what do you focus on? So I said that they are compounds. They are compounds. They are elements. So their properties are definite. Their properties are definite. Okay, and some important physical properties. Some important physical properties are ये page number 40 and 41 में है. Okay, some important properties are, just list down the properties. Properties are, number one, I said that they have crystalline structure. The word crystalline का मतलब होता है the atoms have a very definite arrangement. The atoms have a very fixed type of organization, the crystalline. And they have something called as cleavage. Cleavage are something like planes of weakness. Say I have some mineral here. Okay. In this mineral, maybe this plane is a plane of weakness. This plane is, so imagine this is a mineral, and maybe this plane is a plane of weakness. Maybe this plane is a plane of weakness. So if you strike along the plane, this block आराम से अलग हो जाएगा. And that's how they do polishing of diamond. And we say, no, 7-cut diamond, 8-cut diamonds. So diamond has certain planes. If you strike it at a right angle, that part can easily slip. It is not breaking. Okay, breaking is different from, it's like, you know, say I have got a stack of playing cards. Okay, one is I can cut the card. Second is I can remove the cards very smoothly layer by layer. Okay, so think of cleavage like I'm removing the cards layer by layer without actually breaking it. Okay, it's like think of a wafer, or think of you know, your biscuits. Okay, there are cream biscuits. Cream biscuits में layers होते हैं. Okay, without breaking it, can I remove the layers very smoothly? So think of that kind. Okay, so those planes of weakness are called as cleavage. A cleavage gives typical shapes. It's possible only because it has some kind of crystalline structure. Okay, but if you don't break along cleavage, then the minerals can fracture. Okay, so it's like, you know, you have a stack of cards. You can remove the layers, or you can cut across. If you cut across, the whole thing gets distorted. Okay, so minerals have crystalline structure, minerals have cleavage planes, and minerals also have a fracture. They'll break, they'll shatter. Agar diamond ko aapne polishing mein, if you don't keep in mind those cleavage, it'll completely shatter. And that's you know, the examples where you can go bankrupt by simply shattering one diamond. It's so expensive. That's why you require a lot of skills in polishing the diamonds. Okay, so fracture is one of them. Luster. All minerals will have some shine. Luster is shine. So crystalline structure, cleavage as property. They have they are vulnerable to fracture. They have luster. Luster is shine, and apart from this, they have fixed melting points. They have fixed melting points because they're compounds or they are elements. They are fixed melting points. They have colors. The colors are also their property. They have colors, and they also have a property of streak. And see what happens if you take a mineral and you rub it along another surface. It will leave a line. Okay, that line is called as streak. So in your book it says, streak is the color of the ground powder of any mineral. It may be the same color, okay, or it can be different. So when you take a surface and you strike it, you rub it, so the mineral will leave a color line. Okay, the line may have same color as the mineral, or even different color also. Okay, we call that as streak property. Okay, so they have ek to diamond or the mineral on its own will shine. Second is you rub it on something, it leave a line. The line will have a color. Sometimes the color is same as the mineral or it can also be different. That's called a streak. And the rest is, of course, they have hardness, they have gravity and so on. So these are some key words you should know. That they have luster, they have a streak, they have cleavage, and they are crystalline. Okay, that's how you differentiate minerals from each other. Yesterday I mentioned they have a hardness, and the hardness is measured along a scale called as Mohs scale. Mohs scale mein, softest is talc. इसमें लिखा नहीं है, just know this. Softest is talc, and the hardest is diamond. Okay, so इसका numbering होता है 1, 2, 3, 4, 10 जैसे numbering होता है. The Mohs scale is a way of knowing the hardness of a mineral. Okay, now it is given. It is given. Hardness, it says talc is softest, then gypsum, then calcite, then fluorite, apatite, feldspar, diamond. So 10 grades of hardness. Page 41 under that property hardness. Okay, so just mention in your notebook and go back to your room and again have a look at it. Okay, so I'm done with these properties. Then I was discussing the silicate group. Silicate group of minerals. There are many of them. I said you remember 4 or 5 of them. You remember quartz, one of the most abundant and one of the hardest silicates. Quartz is one of the most abundant of minerals. It's abundant of silicate minerals. It's also the hardest silicate mineral. Then I said you should know feldspar, and you should know amphibole, pyroxene and olivine. अगर ये देखना है, your book also mentions some of these. Oh, the new one. No, it's not in. Okay, fine. You just remember this for now. And I gave you some properties about how these are the non-ferromagnesium silicates. These are ferromagnesium silicates, and the difference of property. These are the lighter ones, and these are the harder ones. These are the denser ones, but these are the softer ones. Denser and these are softer. Olivine, I mentioned, is found entirely inside the mantle. It's only found inside the earth. Okay, inside the mantle, not on the continent. Olivine. Okay, then we moved on towards rocks. I discussed the property of igneous rocks. I discussed the properties of sedimentary rocks. There are at least 4 or 5 questions asked around sedimentary rocks. Okay, examples kya hai, properties kya hai. And I was starting to discuss metamorphic rocks. Discuss metamorphic rocks. Igneous rocks because of molten magma. Igneous rocks, they can be intrusive, they can be extrusive, they can be large crystals, they can be small crystals. They do not have layers. Igneous rocks will be azoic, they will not have fossils. And igneous rocks, we said whenever we talk about intrusive, we talk in the context of the continents. I differentiated between igneous rocks and igneous landforms. Igneous landforms, we always talk about that they are formed within the continental crust. We don't say landforms inside the mantle. Although rocks, I can say they are inside the mantle. Yes, Arvind, you also have mica, muscovite, biotite, but I'm skipping all of it. You don't need all that for your prelims at least, for the GS. Okay, so this was the igneous rocks. I give examples, granite, diorite, andesite, and basalt. Sedimentary rocks, these are softer, that the consequence of sedimentation and cementation. Sedimentary rocks will have layers, sedimentary rocks will have fossils. At one point I forgot to mention here, sedimentary rocks are found, okay, only on the crust. You don't have sedimentary rocks inside the mantle. They are found only on the crust. Or crust may be, okay, they are more likely on the continental crust. They are not part of ocean crusts. They are part of the continental crust. Okay, because see, for sedimentary rocks, what do I need? Okay, what do I need? I need sediments. I need sediments must accumulate. I need sediments to compact. Sediments must cement, and then they are forming rocks. Okay, the sedimentation, erosion should happen. Okay, so what happens is, if I have continents here, so this is the continental block, I'll talk about that today itself, and say this is the ocean layer here, and say this is the water of the ocean. Okay, so what happens is, on the ocean floor, the sediments may be here, but itna thickness layer nahi hai that I will have compaction. Okay, plus it's all water here. Okay, so on the ocean floor, the sediment thickness is not much, and we'll talk about something called a subduction, where the entire ocean ultimately gets subducted, destroyed. So sediments do not accumulate long enough to become sedimentary rocks. Although oceans do have sediments, but they will not have sedimentary rocks. But yes, I can have sedimentary rocks here. Ye continent hai. This is the continental crust. This is the ocean crust. I'll talk about this today. They are different. So I don't have on the ocean crust. Under the water, on the edge of the continent, yahan par ho sakta hai sedimentary rocks. This area can have sedimentary rocks. Essentially, if I ask you a question, you tell me, can we find oil and gas in the deep ocean or not? Okay, can we find oil and gas in the deep ocean? Deep ocean ka matlab hai, okay, you are looking at these areas. If I drill here, can I have oil and gas or not? If I drill here, can I have oil and gas or not? The crude oil. So the crude oil and the gas formation is always associated with marine sedimentary rocks, okay, which are formed here, not here, not here. Whenever you have drilling of the ocean for oil and gas, you don't drill in the open oceans, you drill along the shelves. Okay, the shelf of Persian Gulf, the shelf of Arabian Sea, the shelf of Gulf of Mexico, the shelf of Arctic Ocean. Okay, so this area, this boundary areas can have sediment rocks and not the deeper oceans. Remember this. यहाँ पर कुछ और type का gas होगा, but not the type of gas and oil that we know of under crude oil. Okay, so sedimentary rocks, I said, they are features of the continental crust. Okay, and this crust also extends into what's called as the continental shelves. Okay, that's why these zones can have crude oil and gas. These zones can have crude oil and gas. Arvind, what's an aquifer? Aquifer, aqui means water. A fur basically meaning rocks. So aquifer are rocks which can store water. So sedimentary rocks are the most common aquifers. They're also aquifers because they have air spaces, they have gaps, okay, they can store water. know, Parnika, the waves that you see are in a very narrow zone here. Yahan waves hote hain. You don't have waves here. Okay, and here something else happening. The sediments is compressing because of subduction going on. Okay, so you remember for now, waves are not features of all the waters. Waves are features of the surface. Yahan hote hain waves. You not have waves in the deeper part here. Okay, Parnika. Okay, so you know about sedimentary rocks, and I gave examples of sandstone, limestone, chert, conglomerates, breccia, and so on. So let me continue, unless you have some doubts. Let me take up now metamorphic rocks. Metamorphic rocks. Any questions on what I discussed yesterday? Any doubts on this? Okay, metamorphic rocks. Metamorphic rocks, I said, these are rocks that are dramatically transformed. They are transformed because of temperature, they are transformed because of pressure. And the ones because of pressure, we call this as a dynamic metamorphism. Those because of heat, thermal, we call this as thermal metamorphism, or you can also call this as contact metamorphism. Okay. The metamorphism can be contact metamorphism, can also be dynamic metamorphism. And metamorphism, okay, there are this metamorphism, if it happens over a very large area, then we call this as a regional metamorphism. And this is where I left you yesterday. They are rocks which have been dramatically transformed, transformed because of pressure, because of temperature. If the transformation happens for a large area, we call this as a regional metamorphism. And remember that in the transformation, it is not this or this. Generally, this happens together. Both happen together. The degree may vary. In some case, the pressure is more important. In some cases, the temperature may be more important. But you generally have the impact of both the conditions. Yeah. What is your doubt? Let me see. Karst topography formation kaise hota hai? Abhi bas Dipanshu, let's no karst limestone. I'll discuss. Okay, maybe the landforms. Abhi nahi. Okay, so this now. Some properties mein, metamorphic rocks are also crystalline. They're also crystalline. Metamorphic rocks are generally hard. They also do not have layers. They do not have layers. They are unstratified, but they have bands. What happens is the layers fuse completely. You cannot separate the rocks anymore. You cannot separate the layers anymore. But what you can see is, ये rock hai, you can see the bands like this. It's like the whole thing has been completely fused. आप अलग नहीं कर सकते. In sedimentary rocks, you can separate it. In metamorphic rocks, you can't separate it. They have bands. They are bands. And metamorphic rocks can be both. They can be igneous metamorphosed, or they can be sedimentary metamorphosed. So if the rock is from igneous rock, we call that as igneous metamorphosed. If they are from sedimentary rocks, we call that as sedimentary metamorphosed. Some examples के लिए. Okay. Now some examples. One more fact I should have added, that the metamorphic rocks, properly called add kar lo, metamorphic rocks, they also have foliations. Okay. They also have foliation, F-O-L-I-A, foliations. No. Foliation is related to the crystal structure. Okay. Bands are the visible layers. Add kar lo. Foliations are the arrangement of the minerals. Foliations are the arrangement of the minerals. It's a consequence of their crystalline structure. Consequence of their crystalline structure. Whereas I said the bands are visible distinct color zones. They are visible distinct color zones that are because of the layered structure of sedimentary rocks. Because of layered structure of sedimentary rocks. Okay, and remember again, not all metamorphic rocks will have foliations and bands. Not all metamorphic rocks will have foliations or bands. It all depends on, जैसे अगर वो igneous से बना है, very unlikely it will have bands. Okay. Generally, the sedimentary metamorphose will have bands. So not all igneous rocks have foliations. Not all igneous rocks have, not all metamorphic rocks have foliations, and not all metamorphic rocks have bands. जैसे नीस एक rock है, नीस. नीस will not have foliations. नीस is a very common metamorphic rock. It will not have foliations. Examples you should know. पूछा हुआ questions हैं. Sandstone. Sandstone metamorphosis gives us quartzite. Limestone metamorphosis gives us marble. ये quartzite वाला पूछा हुआ question. One of the most common metamorphic rocks we have, quartzite. Granites metamorphism gives us gneiss. It's a very common rock of the peninsular plateau. It's a very common construction material. Gneiss. Granite forms gneiss, G-N-E-I-S-S, gneiss. Then a shale. A shale or mudstone. Mudstone. इसके बहुत सारे possibilities हैं. Shale can form a slate, can form a schist, okay, can form phyllites, and even a slate and schist can form phyllites. The root, shale is a sedimentary rock. ये sedimentary rock है, mudstone or shale. Slate and schists are metamorphic. Generally, slate schists, they are formed because of dynamic metamorphism. Phylite is formed because of contact metamorphism plus, of course, dynamic. Where pressure, temperature, both is very high, then more likely to have phyllites. So these are related to each other. Shale forming slate, schist, and phyllites. In fact, the fold mountains, some of the common rocks of fold mountains are limestone, बहुत common होता है. You also have sandstone is very common. Even shale is very common. Limestone because fold mountains have marine origin. Okay. Why limestone? Because fold mountains have a marine origin. The sediments come from the sediments of the seas. That's why they have limestone. Sandstone, shale, also called deposition. Now, because they have shale, fold mountains will also have schist and phyllites. In fact, schist phyllites are very common in Himalayas. Schist and phyllites are very common in the Himalayas, one of the most common rocks, and they are very important construction material. Khaskar schist and phylite, they are very important a construction material. And yesterday I told you, wherever we have shale and sandstone, we can also have oil, because there are air spaces, okay, in which the oil can accumulate. Okay, so that's how we have a shale oil and we have shale gas. Shale oil and shale gas. Of course, ये sedimentary rocks हैं, but fold mountains therefore will have all fold mountains. You can add a point here, because the fold mountains have marine origin. Because fold mountains have marine origin. Okay, they have these rocks and also have resources of oil and gas. They have limestone rocks, sandstone rocks, shale rocks, and also have resources of oil and gas. Oil and gas. Yeah. Foliation, lineation. Foliations are essentially between the crystals, and lineations are between the crystal layers. ठीक है, और bands तो आपको दिखाई देगा ऐसे layers की तरह. Yes, you're right. Metamorphic rocks also will not have fossils. Correct. I forgot to mention that. आप add कर लो. Metamorphic rocks also do not have fossils. They won't have fossils, because it's high pressure, high temperature. Whatever fossil may have been there now gets destroyed. The imprints can be found. It's interesting. If you have metamorphic rocks, आपको imprint दिखाई देगा. यहाँ पर कुछ life form था शायद, but you cannot remove that. Fossil का मतलब क्या होता है? The bones are preserved, and you can remove the bones. Okay. In metamorphic rocks, they can become like a print. Okay. You know that यहाँ पर life form था, but you cannot remove that as a fossil bones. Okay. So metamorphic rocks will not have fossils. Okay. So what's your doubt? Ask me. Treat them as same right now. Debarga. उतना deep depth में मत जाओ. Know these terms. That's all. Water bands. Okay. Essentially, you can say something like, the term cleavage I use for minerals, uska corresponding term for rocks is foliations and lineations. If I talk about only minerals, I'm talking about the cleavage. When they're part of a rock and the rock will have zones of weaknesses, then we call that as foliations and lineations. Okay? Okay. So that's about these rocks. Page 43 has a rock cycle diagram. Okay, I'll suggest you go back to your room and you draw this. Okay, so I will quickly show this to you. There is sedimentary rock, there is sedimentary rock, there is metamorphic rock, there is magma. From the magma we have igneous rock. Metamorphic rock can become magma. Okay, the sedimentary rock can become metamorphic rock. Igneous rock can become metamorphic rock, and igneous rocks can become sediments. Even the metamorphic rocks can become sediments. The sedimentary rocks can also become sediments, and they again become sedimentary rocks. Okay, this is what is called as your rock cycle. Okay, so the igneous rocks because of weathering, breakdown. Metamorphic rocks again because of weathering, breakdown. Sedimentary rocks again because of weathering. Sediments. The sediments because of lithification. Okay, they become sedimentary rocks. The sedimentary rocks can also become magma because of melting. Okay. Even igneous rocks can again become magma because of melting. Okay. So this is something like your rock cycle. Okay. So बना लो इसको. ये sediments हैं. Sediments, sedimentary rocks, metamorphic rocks, magma and igneous rocks. Yeah, weathering and erosion. Weathering and denudation. How schist is formed? Schist also is formed because of temperature and pressure, but temperature, okay, compared to shale and slate is higher. Okay, schist can form from shale, schist can form from slate. Schist can form from shale, and schist can also form from slate. But compared to phyllites, the temperature required for schist is lesser. We have shale, we have slate, we have a schist, and we have phyllite. Okay. Sorry. A shale can become slate, a slate can become schist, shale can become schist. Okay. Slate, yes, slate. Slate can become phyllites, a schist can become phyllites, and even shale can become phyllites. Phyllite requires more temperature, more temperature, more temperature. This is more of pressure, some temperature. This is pressure plus some temperature. Temperature for phyllite required is higher. I believe, sir. Okay, let's move on. So I'm done with the rocks and the minerals. It's an important section. Okay. Now let's move on towards what is the structure of the earth. The internal structure of earth. The internal structure of earth. Now see, we'll not get into too much of details on the structure. Like I said, the focus is what type of questions asked and what is most important for your prelims work and some bit of main, because these questions are not a part of mains either. Okay, so don't go too deep in this. Have some idea and we'll move on. Some other things we will go a bit more deeper. Structure mein, essentially it is about the internal organization of the Earth's interiors. Plus what is the composition, plus what are the properties of the layers. This is what I'm studying. The Earth, what is it made up of interiors mein? What is its composition, what is its arrangement, okay, and the properties of the layers. Are they hard, are they soft, do they have high melting point, low melting point, are they fluid, are they solid, ye properties ho gaye. Okay. Now, there are two schemes. One is called as the chemical differentiation. The chemical differentiation. The other is called as the mechanical differentiation. The chemical differentiation and the mechanical differentiation. The mechanical differentiation is based on the strength and the rigidity of the layers. It's based on the strength, it is based on the rigidity of the layers, how hard or soft the layers are. Okay. And the chemical differentiation is based on the composition. What type of rocks, what type of minerals, it's based on composition. Now, the chemical differentiation mein, we have three layers. We have the crust, we have the mantle, and we have the core. I'm sure all of you know this. I'll just quickly revise it for you. The crust, the mantle, the core. The crust is of two types. The crust is continental crust and the crust is ocean crust. Okay. The continental crust, it is thicker. Average thickness more than 30, 40, 50 kilometers. In some places, even as much as 80 kilometers. They are thick. They are thick. So I said, your NCRT says 30 kilometers, but it can be more. It can be 60 kilometers, it can be 80 kilometers also in some places. The thickness is more and it varies, thickness. The continents are made up of granites, they are made up of diorite, they are made up of andesite, and it's also made up of sedimentary rocks. Okay, the continents are thicker. Continents have a thickness. Your NCRT says 30 kilometers. Can also be more. I said 60, 80 kilometers in some places. And the composition is the granite rocks. They can be diorite. I mentioned yesterday diorite rocks, very common. They can have andesite rocks, and they can also have lot of sedimentary rocks. And the continents are lighter. They are not very dense. A density of about 2, 2.5, the NCRT says 2.7. Okay, so lighter, okay, rocks, they are less dense, they are lighter. And continents on average are acidic rocks. ये सारे rocks acidic हैं. Okay, not basic, they are acidic rocks. Granite is acidic, diorite is acidic, andesite is intermediate towards acidic rocks. And the oceans are thinner. They are thinner, 1 to 3 kilometers, NCRT says 5 kilometers. No worries, much thinner than your thickness of the continents. Generally 1, 2, 3 के अंदर ही होता है kilometers. They are mostly basalt rocks. Basalt and also gabbro, but not as abundant. Basalt rocks, gabbro rocks. Oceans are dense. Density of more than 3, they are dense. And the oceans are basic. The oceans are basic. Online, are you all able to note as I am speaking? Okay. No paragraphs, just the keywords, key heads. ये facts पता होना चाहिए. These will not be questions in your mains. In prelims, you just must recognize the term, that's all. So no paragraphs as such. Basic, they are basaltic and gabbro, they are denser and they are thinner, not very thick. That's why when we draw the crust, we always show the oceans as far more thinner than the continents. So this is the ocean layer. This is ocean layer, and this is the continent. Continents are much more thicker. Oceans are much more thinner. The type of rocks of the oceans are different from the type. Of course, a part of the continent is also submerged. Okay, this part or ये part पानी के अंदर है. Okay, but ये continent rocks. But these are rocks of the continent. Oh, keeps disappearing. Okay, they are continent submerged. ये अलग है. This rock is different from the rock we have here. Okay, I think the crust is fine, all of you. Okay. Then about the mantle. Okay, about the mantle. Now, mantle is more than 80% of the Earth's volume. More than 80% of Earth's volume, and more than 60% of the Earth's weight also, because it's a very large zone. Mantle is the largest. It is the largest zone. 80% by volume and more than 60% by weight. And this mantle, okay, has three layers: the upper mantle, the middle mantle, and the inner or the deep mantle. The upper mantle till around 350 400 kilometers. The middle mantle till about 700 900. The deep mantle up to 2900 kilometers from the surface on average. And in general, the mantle is more of olivine rocks, minerals, sorry, or more of olivine minerals. Olivine और olivine के बहुत सारे variants हैं. Olivine is a mineral which is not found much on the crust. होता भी है तो बहुत trace होगा. Olivine, one of the densest silicates, it makes up much of the mantle of the interiors. And remember one property here, that mantle in parts are molten, and the molten mantle can also start flowing. Not everywhere. Mantle in parts is molten, and this molten mantle can circulate. It's called as convection cells. It can circulate. It's called as convection cells. So if I show the diagram, this is the continent, this is the oceans. So if this is the interiors of the earth, something like this here, and say this is the mantle here. This mantle in parts, it can be molten here, it can rise up and circulate and again come down here. It's molten, it can rise up, it can circulate and again come down here. So the mantle, it can be at any layer, it can be here also. Okay, circulating maybe here. At different depths, there can be circulation. We call these as convection cells. These are the convection cells of the mantle. But remember, mantle is solid. Inside the mantle, these circulations happen. Inside the mantle, these movements are happening. One of the analogies I give is, imagine your own body. Your own body is solid. Inside the body, you can have veins and arteries with blood moving. Inside the body, you can have fluid moving. But the body itself is largely a solid. So imagine that kind. These are conduits, ये passages हैं in which the molten mantle can flow. Okay, so mantle has convection cells. These convection cells are the source of volcanism. Whatever volcanism we have, they're linked to some of these convection cells. Okay, they are linked to volcanism. That's about the mantle, and the deeper layer is the core. The core is again two layers. We have the upper core or the outer core, and we have the inner core. The upper core or outer core, this is fluid. This is moving. This is circulating, it's moving. The inner core is solid. It is solid and it is iron rich. It is solid and it is iron rich. So it's something like this is your continent, this is your ocean, this is the outer core, this is the inner core. So think of your earth structure something like this. This is the mantle. You can all draw this if you have not. This is the core, outer. This is the inner core. The mantle has 3 layers. So 350, 400 kilometers, 790 kilometers. This is 2900 kilometers. And this is 4300 kilometers from the surface. This is continent, ocean, this is continent. Okay? Okay. Now, some facts you should know about is, back to your core, the outer core has a density of approximately 11 to 12. The inner core has density of 13, 13.5. The outer core has density of 11 to 12, 11.5, 12. And the inner core has density of 13, 13.5. This corresponds to the density of iron. Okay. ये जो less density है, it is because of silicate impurities. The outer core has a lesser density because of silicate impurities that lower the melting point. And therefore the outer core is molten. It lowers the melting point and therefore the outer core is molten. और ये जो arrangement है, this arrangement where we have a molten outer core with loose electrons moving around iron rich inner core. This creates geomagnetism. The molten outer core with loose electrons. Electrons are loose, they can move with loose electrons, and with the inner core, which is iron rich inner core. This arrangement creates geomagnetism. The arrangement creates geomagnetism. The term we use is, it is something like a self-induced, self-sustaining dynamo. The Earth's interiors, the core behaves like a self-induced or a self-sustained dynamo, D-Y-N-A-M-O, dynamo. This is responsible for Earth's geomagnetism. Okay. Having said this, in the chemical itself, there are layers called as discontinuity. These separate the distinct layers of the interiors. The Earth's interiors have discontinuity, D-I-S-C-O-N-T-U-I-N-I-T-Y, discontinuity, that separate the distinct layers of the interiors. There are many of them. You remember 2, 3 of them. That the layer that separates crust and mantle, we call this as Moho discontinuity. The layer that separates mantle and the outer core, we call this as Gutenberg discontinuity. The layer separating outer core and the inner core, we call this as Lehman discontinuity. call this as the layman discontinuity. Okay, now, yeah, ignore this. You don't need everything for the GS part. Okay. One thing you may know this, that this crust and mantle का जो discontinuity है, this has a variable depth. It is deeper under the continents, okay, because continents are thicker. In the MOHO, M-O-H-O, MOHO discontinuity, the depth is variable. Okay. Essentially, so if I draw the MOHO, say ये MOHO है. This is the MOHO discontinuity. Okay. So under the continent, it is deeper. Under the ocean, it is shallow. Why? Because oceans are thinner, continents are thicker. Okay. So the depth of MOHO, it varies under the continents and under the oceans. Okay? I don't think you need more than this for interiors of the earth. Okay? You might add 1 point maybe if you want to add here. You can add 1 point. 1 point. लिख लो आप, write down that the mantle is the source of most of volcanic eruptions. The mantle is source of most of the volcanic eruptions. Molten lava can come from shallow mantle. Molten lava can come from shallow mantle, or they can come from the deep mantle. Molten lava can come from the shallow mantle, or they can come from the deep mantle. Deep mantle. Next, the magma coming from deep mantle, the magma coming from the deep mantle is always very fluid. It's always very fluid. It moves very quietly. It moves very quietly. Okay. It is basaltic in composition. It is basaltic in composition. It is not always part of convection cells. It is not always part of convection cells. The deep mantle magma are generally isolated. They are generally isolated vertical columns of moving magma called mantle plumes. They are vertical columns of molten magma called mantle plume, P-L-U-M-E, called mantle plumes. Such mantle plumes create localized volcanism. They create localized volcanism called hotspots. On both continents and oceans, called hotspots, and they are formed on both continents and oceans. See what I'm saying is here, watch here. So say this is the continent, that's the ocean, another continent, and this is the core, inner and outer core. I said these are the mantle layers. and the mantle layer can circulate. We call these as the convection cells. The mantle layers can circulate. We call these as mantle cells. Okay? But there is a special type of magma that this magma it will come and erupt here. Or straight like this. It's not a part of circulations like this. Okay. This is called as mantle plumes. Okay, mantle plumes. So, like it breaks through the crust and comes and forms basalt accumulation. Basalt ka hoga. Okay. This was a question on. You can't hear me online? Online. Am I audible now? Am I audible now? Yes? Dhyanada? Kushi, yes? Okay. The mantle has plumes, but a specialized wala jo hai, coming only from deep mantle, generally from the mantle core boundary. Okay. These are called mantle plumes. And what they form is, they form basalt accumulations. Examples of such basalts, examples of basalts, this is volcanism are, examples of such basalts or such volcanisms are the Deccan lava plateau. The Deccan lava plateau, okay, Hawaiian Islands, the Deccan lava plateau, the Hawaiian Islands. Okay, we have the Azores Islands, Azores, Azores Islands. Yes, Galapagos Islands. We call these as hotspots. Correct. Okay, so the Deccan lava plateau, the Hawaiian Islands, Azores Islands, okay, examples of such type of mantle plumes causing volcanism. So I'm done with the physical division, the chemical division. Now let's look at the mechanical division. Mechanical division. This is based on the strength and rigidity of the layers. Okay. So some people ask me, sir, kya difference hai? Okay. So my common example is this. Okay. I'm repeating for some of you. Say I have a wall. On the wall, I have put a plaster. On the plaster, I have put a POP layer. On the POP layer, I have put some paint. Okay. So if you look at composition, ये सारे अलग-अलग हैं. The paint is different from POP. The POP is different from the plaster. The plaster is different from the bricks. So in chemical composition, you have got 4 layers. But it is almost impossible to remove the paint from the POP. आगे निकाल कोशिश करोगे POP भी निकल जाएगा. So the paint and POP are very well operating like one layer. You can't differentiate. जैसे कि your skin also has 3 layers. But for most of us, we can't separate it. The 3 layers act as one layer. So in terms of composition, there are 3 layers. But in terms of strength, they act as one single layer. So my say fabric, the cloth, it has some paint. Like it has some prints. You can't remove it. They are now fused together. So when they act as one, we call them as one layer in terms of rigidity, in terms of its strength. Okay. So what we know is we have continents, we have the ocean, we have the upper mantle, we have the middle mantle, we have the inner mantle, we have the outer core, we have the inner core. This is deep mantle, this is middle mantle, this is the outer mantle, continents and the oceans. This is in terms of the chemical layering. But what happens? There's a major problem with this. But what happens is, for all practical purpose, the continents, oceans, along with a part of the outer mantle, they operate as one single layer. Okay? So this includes the oceans, it includes the continent, it also includes the upper part of the upper mantle. The whole thing acts as one layer. We call this layer as, yes, the lithosphere. And this is having a thickness of 100 kilometers. Okay, they are distinct layers, they operate as one. Whereas the rest of the upper mantle, this operates as a different layer. We call this as the asthenosphere. This is for a depth of 350 or 400 kilometers. This is the main difference between the mechanical layering and the chemical layering. So this, on your left is the chemical layering. I just now taught crust, continents, crust, oceans, mantle, middle mantle, and so on. Okay. On the right hand side is how the crust and the upper part of upper mantle up to 100 kilometers. This acts as one layer called a lithosphere. Okay. Write down. What is the mechanical differentiation? Mechanical differentiation, or based on mechanical rigidity. Rigidity is, write down, the crust, both oceans and continents. The crust, both oceans and continents, along with the crust, ocean, continent, along with the upper part of the upper mantle, for a thickness of 100 kilometers, act as one unit. They act as one unit. This layer is called as the lithosphere layer. This layer is called as the lithosphere layer. Okay. The lower part, next point. The lower part of the upper mantle, is called as the asthenosphere. It's called as the asthenosphere. Okay. So the rest of the mantle, okay, this is called as the mesosphere. And this is called as the core. In some books they might write this as the barysphere. हमारा main discussion mechanical differentiation, we have lithosphere, asthenosphere, mesosphere, barysphere. Yes, for some reasons, because of high temperatures, also called as pyrosphere. I mean, see, keep it simple. Don't take up so much of depth. Okay. हमारा main discussion है discussing this. It refuses to listen. The lithosphere, so the layering. So in the chemical layering, we have crust, mantle, and core. In the mechanical layering, we have the lithosphere, asthenosphere, mesosphere, and the barysphere. Lithosphere is a crust along with the part of the upper mantle. Okay. The remaining mantle is asthenosphere. And we have the middle and the deep as mesosphere, the core as the barysphere, the upper mantle. Is it okay, all of you? So now our discussion point is that the lithosphere is not a continuous segment of the earth. So if you look at the earth here, so this is the outermost layer. Okay. What I'm saying is that this layer is not a complete sheet. This layer is the lithosphere, which is broken up into parts. ऐसे ये टूट गया है. The lithosphere is not a continuous, okay, uninterrupted segment. Write down, please. The lithosphere is not a continuous, uninterrupted segment or an uninterrupted layer. It is broken up into distinct blocks, called the plates. Blocks called as the plates. So इसमें maybe this is the continent, some part is ocean, this is the ocean part, this is the continent part. Okay, ये टूट गया है. This is broken into distinct segments like this. Each is called as, okay, a plate. It's broken up into blocks, and the blocks are called as lithospheric plates. Next, these lithospheric plates, they float over the asthenosphere. They float over the asthenosphere. Okay. ये जो layer है, this is up to a depth of 100. This is the remaining part of upper mantle up to 350, 400 kilometers. This is the asthenosphere on which these blocks are floating, on which these blocks are moving. Okay. Next point, write down. The asthenosphere has a peculiar property. The asthenosphere has a peculiar property. It is majorly made up of olivine. The main mineral, the पूरे mantle mineral है olivine, but यहाँ पर ज़्यादा है. In the other layers, there are other variants of olivine. Okay. The astronosphere is majorly made up of olivine, which has a property of, losing rigidity if pressure is applied on it. It has a property of losing rigidity if pressure is applied on it. So जो astronosphere है, the astronosphere, it is solid. Okay. It is dense. It is dense. It is majorly olivine. Olivine has a property, it will lose rigidity, it will become soft and will flow if pressure is applied. If pressure. So it's like, think of a sponge. A sponge is a solid. You apply pressure, it will get deformed. Remove pressure, it again bounces back. Think of a balloon. It's solid. You squeeze it, it will deform. Remove pressure, it will again bounce back. Okay. So something like this is the astronosphere. It is solid, it is dense, halka bhi nahi, it's dense. Olivine has high density. The density of astronosphere is more than 4 in parts of the 7. But if you apply pressure, it will become fluid. So ये जो property है, this property where it can start to flow, okay, this is called as the semi molten state. And remember, I'm using the word semi-molten because we do not have a better word for this. Okay, in our other material, this property is not a common property. A sponge mein kya hai? Sponge mein, it only gets squashed. It's not that the sponge starts flowing like water. Okay, or even if you have got a rubber आप दबाते हो, it gets squeezed. It's not that the rubber starts flowing. यहाँ पर it will start flowing. In our experience, we do not have this type of a material. Therefore, we use this word, but remember, the astronosphere is not molten. It is solid. एक special property hai of astronosphere. And I said, I'm using this term because I do not have another better word for this. Okay, write down. The behavior of astronosphere, the behavior of astronosphere is a very important part of, how the features and landforms on the earth, maintain their stability. Okay, it's a very important part of balancing. ये कैसे balance होता है? This does it. So for now, don't know this in detail. Just know this. This stability balance is something called as isostasy. Just know this term. That's all. The behavior of astronosphere and lithosphere is part of a phenomena called as isostasy. How the features of the earth maintain their balance, how they maintain their stability. All fine here, all of you? Okay. So do you want to quickly turn the pages and ask me a doubt if you have any? Dekho, check up. No. Plasma state is a molten state under very high temperatures. where the electrons become loose. ये plasma नहीं है. Plasma term I'll use for only the outer core. Okay, not the inner core, outer core. ठीक है? Anybody else? एक बार turn कर लो pages if you have any doubts, any questions. You know, I remember when I started off studying for my preparation and the initial years, most of these was completely new to us because we had no exposure whatsoever. Whatever we knew is what we were told. हमें कुछ भी idea नहीं होता था इसको, एकदम नए नए आके बैठते थे हम लोग. But in today's time, when there is some awareness about what to read, what not to read, there are so many YouTube videos, lot of these concepts आप सुन के आते हैं. You are not completely blank when I am discussing this. In fact, some of you may even know a bit more than what I am teaching. That's a good thing. That helps us maybe validate some points. Okay, so that way we can move faster. Yeah, what's your doubt online? In astronosphere, which metal is found? Metal is the wrong word. Which mineral? Which mineral? It is olivine. Okay, so and olivine has lot of iron and magnesium. We call those as ferromagnesium silicates. Okay, so they have iron and magnesium, but alag-alag nahi hoga metal. Iske elements bolo. What elements we find in the astronosphere or the mantle in general? We find ferromagnesium silicates. That's why they are dense, they are heavy, and they are dark in color. Anybody else? Any questions on this? Okay, let's move on. So I'm done with the interior structure of the Earth. Now, the important discussion is the evidences of Earth's interiors. Most questions are asked on this. Prelims maybe or mains maybe. Evidences of the Earth's interiors. I'll tease this to you and I'll mention the NCERT page also and read it back in the room very fast. Okay, more or less I would have covered this. Evidences of the Earth's interiors. Okay, so what we're saying is, okay, in fact, before this, I could have discussed one more thing. Now, one more point I will discuss before I move on towards evidences, maybe a short, listen to this one. So, if I look at the interiors of Earth, what I realize is that the interiors are layered. Okay. The interiors have density a differentiation, and the interiors are more of concentric zones. Okay, if you look at the interiors, so this is the interiors of the Earth. And the variations, but variations random nahi hai. The variations are layered like this. One layer called as the crust, one layer called as the mantle, one layer called as the core, and so on. Interiors are layered, and the layering has concentric zones. All of them will have one common center here. And the interiors have a density differentiation, where the innermost layer has high density, the outer parts will have less density. The density of the Earth increases with depth. Okay, the outer layers मैंने बताया था density 2 है, 3 है. You come towards the mantle, the density is 4. You go deeper inside, it is 9. You come towards the outer core, it is 11. Inner core, it is 13. That is a density layering of the Earth. Look right on, please. Before I move on to evidences, the interiors of Earth ka some observations. One is, I said, it is layered, and the layering has concentric zones. Interiors are layered and the layers have concentric zones. Okay. And then I said the interiors have density differentiation. They have density differentiation. Okay. There's a pattern to this, that the density progressively increases towards the core. The density progressively increases towards the core. Okay. The inner core is the most dense, 13.5 inner core, and the crust has 2.5, 3. Okay. The question is why? Why do we have this type of layering? Kya reason hai iska? So there are two interpretations on this. Why is it layered and why does it have density differentiation? There are two interpretations. One interpretation says that this is because of nebular accretion. It is because of nebular accretion. The formation of Earth started with some gas. This gas is the cloud, dust particles, hydrogen, helium. Okay. For some reason, it starts to condense, contract. In this condense, contract, something happens called as okay, gravity collapse. Nebular accretion because of gravity collapse, where the dense matter falls inside. यानी गिर जाएगा. Okay. So the densest one is inside, and the lighter ones will remain outside. We call this as the phenomena of gravity collapse. Why does the Earth have this arrangement? One theory says it is because of nebular accretion. Okay. Nebula is what? It is a cloud of gases, a cloud of dust, a cloud of hydrogen and helium. Okay. And this cloud, it becomes solid. Okay. This solidification is called as accretion. Accretion, and this is related to gravity collapse, where the dense matter falls inside and becomes the core, the lighter ones stay outwards. So write 2 lines on this, 2 lines. Okay. That the Earth was formed from a nebula. Earth was formed from a nebula that solidified and accreted. That solidified and accreted. ACCRETED, accreted. And the denser rocks and minerals collapse towards the center. The denser rocks and minerals collapse towards the center. Earth was formed from the nebula. The nebula solidifies, it accretes. The denser rocks, minerals fall towards center, and the lighter minerals remain outwards progressively. The lighter minerals remain outward progressively. That's one idea. The other idea says, this is the idea of nebular accretion. The other idea says that the density differentiation is because of internal heat, volcanism, density differentiation. The difference is because of internal heat, because of volcanism, and that leads to density differentiation. You can add here associated with convection currents and with the mantle plume. Associated with convection currents and mantle plume. Likha aapne? Let me explain this to you. See, what it's saying is, this is the earth. Some gases, some rocks, some minerals, some cloud, dust, whatever. Yes, it is contracting, okay, and it is becoming solid slowly, gradually. So it is saying that yes, nebular accretion must have happened. That's ho raha hoga. But in the nebular accretion, because compression going on, plus there is lot of heat inside, lot of rocks, so the whole thing must have become a solid. Ye ban gaya solid. But it is very hot, okay, and compression, lot of soil starts to melt. Lot of it starts to melt. Because the melting, okay, it can't go inside. Halka hai, melting, it will move outwards. It will move outwards. And when it moves outwards, okay, the inner is hot. Outer part is cold. Okay. So what's molten here will move towards the cold, and while going outwards, the lighter ones will go outwards. And it's like, think of I have air and I warm it. Kya hoga? Air becomes lighter, it will go up. Okay. So in this process of melting volcanism, okay, when lava starts moving upwards, the lighter one moves upwards, the heavier one stays behind. That's how slowly, gradually, the lightest ones comes out and forms the crust of the earth. Lighter ones comes out and forms the continents of the earth. The lightest one comes out, forms the outer lithosphere of the earth. Okay, that's the process. Okay. I'm mentioning this because this is there in the NCERT. Can be part of your assertion reasoning type of questions. There are two lines. In the volcanism of the interiors, the lighter rocks and minerals, they move upward and outwards. They move upwards and outwards, forming the less dense lithosphere and the outer layers. Forming the less dense lithosphere and the outer layers. So if you have NCERT, I'll just tell you the page number kahan par hai. Page number 17, 17. Page 17, there's a section called Evolution of Lithosphere. I'm reading out, you can listen to this, when it says, Earth was mostly in a volatile state during its primordial stage. Due to gradual increase in density, the temperature inside has increased. As a result, the material inside gets separated depending on their densities. This allows for the heavier metals to sink inside and the lighter ones to move towards the surface. With passage of time, okay, it cooled further and condensed into smaller size. And this led to the development of the outer surface in form of crust, okay, and thereafter. The crust, therefore, from the crust towards the core, the density of material increases. And we'll discuss this in the later chapters. Okay, so page 17, read up the section called as Evolution of Lithosphere. that it is molten. Okay, when molten, the colder rocks are rising up. The lighter ones will rise, the heavy ones will go inside. Okay, that's how the outer layers become crust lighter. The heavier ones are the core and the inner mantle. Okay, how does the layering of the earth happen? Okay, so I'm done with this one. Now come to evidences of the earth's interiors. Evidence of the earth interiors. So now we know earth is layered. Earth is layered, we know this, that the outer layers are less dense, the deeper layers are higher density. Okay. We know that astrosphere is semi-molten. We also know the outer core is fluid. Question is, ये सारा हम जानते कैसे हैं? How do I know this? Okay, the radius of the earth is, Earth's radius is about 6400 kilometers. Okay, so how do we know the details? And it's almost impossible to go down and go and check what's happening inside. Okay, this is what we see of the Earth's interiors. The question is, how do we know this? If the Earth's radius is as much as 6400 kilometers. The answer is that there are certain direct studies and there are certain indirect evidences. Direct में आता है study of volcanic rocks, study in the mines, studying the sediments from drilling. Okay, so we actually are studying the rocks. Volcanism rocks are bahar aaya, study that. Okay, the study of the volcanic rocks, study of the mines. Okay, in parts of South Africa, your book says we have gold mines 3 to 4 kilometers deep. And in some parts of oil drilling, the drilling has been done for 10 to 12 kilometers. Okay, so we can know something about the interiors, but ye bhi enough nahi hai. Okay, we rely on the indirect evidences. So we are studying meteorites. We can extrapolate temperature and pressure patterns. We can study gravity variations. We can study geomagnetic variations, and we can study earthquake waves. Okay, you take a list of this. What are the direct ones and what are the indirect ones? Direct ones are study of volcanic rocks, the study of mines, what type of rocks we find in mines, study of sediments sourced from drilling operations, drilling for oil, drilling for gas, we find something. Okay, but these are still very shallow. They don't tell us much about the deep interiors. Hardly we can reach 10, 12 kilometers in some places. So the more reliable ones are the study of meteorites. Like you're studying the rocks coming from outer space, meteorites. Study and extrapolate the pattern of temperature कैसे बढ़ता चला जा रहा है. You are doing mathematical calculations, temperature patterns, pressure patterns you are studying. You're studying gravity variations. Okay, I hope you know gravity is a consequence of mass. Okay, if the gravity variations are there means inside the earth, mass also varies. So gravity variations are related to the density variations. Okay, these points your NCERT lists down. We study the geomagnetic variations and we study the earthquake waves. This is the most important part. I'll elaborate this now. Study of the seismic waves. Take a fresh page. Study of the seismic waves. Study of the earthquake waves. The seismic waves or the earthquake waves. Earthquake waves. Okay. Now, so you keep jotting as I speak, okay? The first point here is that earthquake is vibrations and a release of energy. Earthquakes are vibrations and they are release of energy. The energy release, it can be sound waves, it can be vibrations which are physical, it can also be electromagnetic radiations. Okay, you can hear a sound, an earthquake happens, some vibration is also energy, and there can be electromagnetic radiations. Okay. For a study of interiors, we focus on the vibration related energies. We call these energy as the physical or the mechanical energy. Because the electromagnetic radiations, they do not require any medium. They can move in any medium. But the vibrations that we have, they require a medium. Okay. So we study those. We study interiors, okay, on the basis of the vibration related energy, which we call as the mechanical energy. Because the mechanical energy and its properties, are dependent on the nature of medium through which they pass. The energy is dependent on the nature of the medium through which they pass. It's like I have some energy going. This is medium M1. It comes out in some ways. Some energy going. This is medium M2. This is wave 1, this is wave 1. When passing through medium 1, it converts into wave 2. When passing into medium 2, it converts into wave 3. Okay. So the medium decides how the waves will change. The medium decides how the waves will behave. Okay. So what I'm saying is the mechanical waves and their behavior. The behavior में हम दो चीज पढ़ते हैं. One is the speed of travel and the direction of travel. The mechanical waves and their behavior. Their behavior is the speed of travel and the direction of the travel. How fast they move and how slow they move. They move straight or they bend. Okay. The mechanical waves and their behavior depends on the medium. Okay. ये wood है, इसका अलग behavior होगा. ये अगर iron है, इसका अलग behavior होगा. ये अगर water है, इसका अलग behavior होगा. There is some correlation between the behavior of the waves and the medium through which they are passing. Okay. The medium through which the waves are propagating. Okay. That is the fundamental principle. Okay. Now, based on where the waves are passing, there are two types of waves. Okay. ये जो earthquake waves हैं, based on where they are passing. So this is the earth. Okay. ये earthquake का location है. The wave can pass through the body. The wave can pass through the body, or the waves can pass on the surface. The waves can pass on the surface. So based on the place where the waves are passing, there are two types of waves. We can have body waves and we can have surface waves. So that's one point. Based on where the waves are passing, the waves can be body waves, the waves can be surface waves. The body waves pass through those interiors, surface waves pass on the surface. Okay. Achha. Body waves, these are more important for studying Earth's interiors. अगर मुझे जानना है कि अर्थ के अंदर में क्या है, I will study the waves passing through the interiors. They are more important for knowing what the earth has. Surface waves, these are more important to understand the destruction. Surface waves are the most devastating waves. There are two types of surface waves, L wave and R wave. The surface waves are more destructive compared to the body waves, because body waves, they pass through and go away. The surface में होते हैं, the buildings will shake here, okay, the roads will break up here. The surface waves are more dangerous, and there are two types of surface waves, L waves and R waves. Okay, but for our discussion, because I'm studying interiors, I will study the body waves a bit more thoroughly. That's the next. Based on the vibration nature, based on the vibration of the particles and their nature, body waves are of two types. Based on the vibration of the particles and their nature, the body waves are of two types. Okay? So the body waves can be P waves, primary waves, also called as P waves, or they can be secondary waves, also called as S waves. P waves are longitudinal waves, and the S waves are transverse waves. इस पे 2-3 बार questions आ चुके हैं. The P waves are primary waves, P waves are longitudinal waves, the S waves are transverse waves, okay, or secondary waves. अच्छा. The primary waves में क्या है? Okay, the particles vibrate along the axis of the energy. If energy moves like this, the particles are vibrating along the axis. ऐसे ही कर रहे हैं vibrations. Okay. The P waves, they vibrate along the axis of the energy propagation. इसमें क्या है? The medium will have variations in density. When they come together, more dense. When they move away, less dense. When they come together, more dense. So more dense, less dense, more dense, less dense. So in the propagation, there will be density variations. This is something like sound waves. There will be density variations. They are something like the sound waves. Okay. When they come together, we call this as dense fraction, rare fraction. Dense fraction, rare fraction. Compression, rarefication. Compression, rarefication. That's how they are vibrating, like this. There will be density variations, and they are like sound waves. In the P waves, the particles vibrate perpendicular to the axis of the energy. If the energy moves like this, the particles will vibrate up and down, not along the axis. They'll move perpendicular to the axis. इसमें compression, rarefication, इसमें क्या होगा? Up, below, So crest, trough, ऐसे move होगा. Example of this is guitars, plucked strings. Guitars, plucked strings. When you pluck a guitar, okay, the vibrations of the strings are transverse waves. Okay. So just know this much. What are P and S waves? Now, there are three properties you must know about P and S waves. The properties are, okay, this was the asked question. P waves, they are faster. The S waves are slower. This was the asked question last year. P waves are faster, the S waves are slower. Next. P waves velocity, okay, is proportional to the density of the medium. S waves velocity is also proportional to density of the medium. What it means is, if more density, they will move faster. If less density, they'll move slowly. The velocity is proportional to density in both the cases. Density and also, okay, and P waves velocity is also proportional to the rigidity of the medium. And the same here also. S velocity is also proportional to rigidity of the medium. Means the density means something is dense or less dense. Rigid means, is it hard or is it soft? So both P and S में more density, more speed, more hard medium, more speed. Less density, less speed, soft medium, soft speed. Both cases में. But one difference is that P waves, they can pass through solids, they can pass through liquids, they can pass through gas. Of course, liquid and gas have less rigidity, they'll become slow, but they'll pass through. But S waves can pass through only solids. They can't pass through gas, they can't pass through liquids. So this is where the questions are generally. P and S waves. What are P waves? Longitudinal waves. What are S waves? Transverse waves. What are P waves? Like sound waves. What are S waves? Like the guitar. P waves in general are faster. S waves are slower. Both P and S waves, the velocity is directly proportional, or it is positively correlated with density and rigidity. More density, more speed. Less density, less speed. More hardness, more speed. Less hardness, less speed. But variation यहाँ पर आता है. That P waves can pass through all the mediums. S wave can pass through only the solids. So जहां पर liquid होगा, S wave will disappear. Okay. And one more point for both of them. I mean, the whole evidence is essentially this box itself. One is, okay, because for both of them, because P and S waves velocity increases with rigidity and hardness. If there is a variation in medium, P and S waves, they bend, they have refraction. This is the important point, that P and S waves velocity increases with rigidity and with hardness. It increases with density. Okay. Therefore, if there are variations in the nature of the medium change ho gaya, the P and S wave, both waves will bend. Okay. So what I'm saying is, this is medium 1, this is medium 2. The waves are passing. When they enter 1, they can bend. Enter 2, they can bend. And then come out like this. Okay, medium 1, medium 2. Passing this ways, they can bend. Medium 2, they can again bend. And again come out like this. So waves, jo bending phenomena hai, okay, so add here, therefore, the speed of the waves, and the path of travel of the waves, the speed of the waves and path of travel of the waves, okay, can tell us about the medium of the Earth's interiors. Can tell us about the medium of the Earth's interiors. This is the concept you should know for the P and S waves, and how seismic studies tell us about the interiors of the Earth. यही आपका main box है. All questions are from this part. Okay. So what are the observations? Again, the optional guys, please don't go overboard. Compressibility, that's rigidity, no? PB or SB? Okay. Compressibility is about rigidity. जो compress हो रहा है मतलब वो soft है, right? तो अगर compress हो सकता है and becomes very very dense, okay, उसका भी change हो जाएगा. Water is, yes, water is incompressible, correct? It's fluid. तो मैं बता तो रहे हैं आपको, हम some things are soft, some things are density variations, and some things are phase variations. ठीक है, हम phase और softness को साथ रख रहे हैं, because जो phase है, liquid है, essentially वो non-rigid है. That's about it. ठीक है. So if you know this much of property, you can solve all the questions on this topic in your prelims. Okay. So what are the observations? What are the observations of P and S waves through the Earth's interiors? In the optional, you will need more details. For the GS, some basic points. Basic points is, number 1, both P and S waves, gradually increase in speed in general through the interiors. Both P and S waves, they gradually increase in speed in general when passing through the interiors. P and S waves का in general हम बता रहे हैं जो speed है वो increase करता है. Which basically means as we go inside, the layers become more and more dense. The layers become more and more dense in general. That's one. Number two, both P and S waves, record sudden fall of speed in the astrosphere. Both P and S waves record sudden fall in speed in the astrosphere. Why? Because of, they have less rigidity, they are softer. They are having high density, but they are softer. So both P and S waves में there is a fall of speed in the astrosphere, because astrosphere is less rigid. The third point, both P and S waves pass through the mantle. Both P and S waves, they pass through the mantle. Beyond the mantle, S cannot pass. Beyond the mantle, the S waves cannot pass because the outer core is fluid. Because the outer core is fluid. P waves continue, but at a lesser speed. The P waves continue, but at a lesser speed. हो गया आपका? When you hit the outer core, S waves cannot pass through liquid medium. They can pass only through solid medium. And the next point is, both P and S waves bend outwards when passing through the mantle. Both P and S waves, they bend outwards when passing through the mantle. Because in general, through the mantle, the density of the rocks increases. Because through the mantle, the density of the rocks increases. ये आपको 5-6 पॉइंट याद रखना होगा. You do not need more than this for your GS. Okay, some of us are optional zealots. We overdo this, not required. Always जब भी doubt हो ना कितना पढ़ना है, look up the PYQs, कैसे पूछा जा रहा है. Okay, इतना काफी है. Okay, you need to focus more attention on other subjects then. Okay, now we have the P and the S wave का diagram. The diagram you should know. The diagram, I'm drawing P and S waves separately. So S waves का diagram में, S waves, they bend outwards, S waves bend outwards, S waves bend outwards, S waves bend outwards. They are bending outwards. Okay. But the moment they hit the outer core, इसके बाद में they can't pass. So they can pass only up to this much. Okay. This angle, the angle at which they're coming out here, this angle is called, this is 105 degrees angle. This is for the S waves. While going, they bend outwards. Okay. This is the source of earthquake. We call this as the epicenter or the focus. अगर वो surface पे नहीं है तो I'm assuming earthquake surface पे है and they're bending outwards. Okay. S waves, they come out at 105. So beyond 105, we call this area as the S shadow. I'm sure all of you have heard this in some way or the other. I'm only putting that into your short discussion. That's all. तो S वेव का कैसा डायग्राम होता है? ठीक है? The S waves emerge at 105 degrees, and beyond 105 degrees we have the S shadow zone. Now we draw the diagram for the P waves. For the P waves, that's Earth's interiors. Same thing, P waves bend outwards, bend outwards, bend outwards, bend outwards, bend outwards. They become tangential here. This angle is same as this one. This also is 105 degrees. This also is 105 degrees. Book says 105. It can vary. 105, 109, 103, it varies. S waves can't pass, but P waves, they bend inwards and they have some changes. They again come out here. They bend inwards, they change, and they come out here. They re-emerge. This angle is around 140, 145, 150 degrees. Okay. So for P waves, this zone has no P waves. This zone has no P waves. यहाँ पर P waves नहीं है, यहाँ पर P waves नहीं. It's called as the P shadow zone. This part has no P waves. This part has no P waves. This part has no P waves. So S shadow zone is beyond 105 degrees. लिख लो. S shadow zone is beyond 105 degrees, whereas P shadow zone, whereas the P shadow zone is between 105 and 140 degrees. Beyond 105 and 140 degrees. But this value varies. NCERT says 145 degrees. So perfectly fine. 145 degrees. So in your textbook, this is page number 22, 23 and 24. Page 22, 23 and 24. 23 has what is the shadow zone? Okay, so in your notes you keep mentioning, okay, the page numbers also. You can go back and check what is the P and S. So on the PS mein, there have been 2-3 questions prelims mein, and once they've asked question your mains also. Now this I think is the most important discussion of the interiors of the Earth. All fine, all of you here? Now right next page likh lo aap. Earthquakes, zones of the Earth, earthquake zones of the Earth, and measuring earthquakes. I'll just give you a brief write-up for now. Earthquake zones of the Earth and measuring earthquakes. Okay. So earthquakes kahan hote hain? One is that earthquakes can be both both natural causes and also because of man-made causes. Man-made causes में say drilling, construction, nuclear tests or any bomb tests, tunneling. Okay, you can have, yes, a reservoir induced seismicity. The dams can cause earthquakes. Okay. Yes, example of RISs in the Koyna Dam. So I think most of you know this, man-made. Natural causes, they are related to plate movement. They are related to volcanism. They are related to natural slopes instability. Okay. They're also related to landslides and, yes, and subsidence. Why do earthquakes happen? Earthquakes are related to plate movements. Plate movements are related to rifting. Take a look, please, all of you. Okay. Why do we have earthquakes? Because of plate movements, because of rifting, because of volcanism, because of your slopes instability, and linked to the slopes instability is landslides and subsidence. Okay. Now, about natural, if I relate it to volcanism and tectonics, these are the more common reasons. Tectonics mein, we find that the earthquake zones are along what we call as plate boundaries. The earthquake zones are along plate boundaries. The earthquake zones are along locations of volcanic eruptions. Along plate boundaries, along volcanic eruptions. Next point here is earthquakes which are from the deeper earth. These are less destructive. Earthquakes that come from depth of more than 300 kilometers, they come from depth of more than 30 kilometers. They are less destructive because by the time they come on the surface, they have become weaker. Okay. Earthquakes that come from the deeper mantle, deeper interiors, they are less destructive. These earthquakes are generally more than 300 kilometers depth or from more than 30 kilometers depth. These type of earthquakes are coming from the deep mantle. They come from the deep mantle. The earthquakes which are shallow, which are near the Earth's surface, these are more destructive. The shallow ones, these are more destructive. Okay. And the more common shallow earthquakes are, okay, right on point here, the more common shallow earthquakes are along active fold mountain regions. The common shallow earthquakes are in the active fold mountain regions. Fold mountain regions. Okay. Now the discussion point was that when we are studying body waves, when we are studying interiors of Earth, which type of earthquakes are we studying? Are we studying the deep ones or are we studying the shallow ones? ये अर्थ है, मैंने ये डायग्राम बनाया था, तब बताओ ये कैसा अर्थक्वेक है? शैलो वाला है कि डीप वाला है? Shallow वाला है. Okay, this was one of the questions. Okay, that in the earthquake studies, we are studying the shallow because I need the earthquake near the surface here. So most of the earthquakes which are associated with the fold mountains, they are the more valuable ones for interiors of the earth study. Okay, so write down here for earthquake evidences of Earth's interiors, for earthquake evidences of the Earth's interiors, because we are studying body waves passing through the entire interiors. Because we are studying the body waves passing through the entire interiors, the more valuable ones are the shallow focus earthquakes, or the more relevant ones are the shallow focus earthquakes that develop near the active fold mountain regions. That develop near the active fold mountain regions. कोई भी earthquake जिसका focus shallow है, the focus of the earthquake is less than 300 kilometers, less than 100 kilometers, they are more relevant for our studies and not all types of earthquakes. ठीक है? So that we have taken care. Yeah. So that's for today. I didn't give a break. I thought I'll finish off at one stretch. Tomorrow we will spend some time discussing important landforms. Landforms were not asked for some time, but my guess they can start asking again. So my suggestion again for tomorrow's class, please bring your NCERT textbook. No point studying all landforms from everywhere. We again overdo this. There are about 20 odd landforms which are more important, okay, and you can focus on those. Huh? Kal elections? Oh, okay. So, oh wow, so I didn't anticipate that. So anyways, then for tomorrow's class, you just look at the Telegram channel. Let me announce it. I forgot about it. I have not told the institute also. I'll ask what the status is. Logically speaking, yes, agar daily elections hain to it should be shut down because that's a mandate. But let me find that out. Agar announce nahi karenge to class hai. Okay, we'll let you know. Otherwise, okay, you'll have your day off. Any case, kal ho ya parson ho, make sure that you get this textbook with you, please, all of you. Yes, shallow focus earthquakes are more destructive also, correct? Because they are near the surface and they cause maximum damage because of their force and energy. Yeah, Preeti, ab to pura hi break kar diya maine. Okay, so Telegram link, I presume most of you would be there. I have a general one which is Edukemy for IAS or Shabbir's Edukemy channel, Telegram channel. Okay, you can look that up. In fact, yeah, all of you watch. For the last 2.5 months on the Telegram channel, we have been practicing some previous year's questions. Now I'm changing track. अब ऐसा थोड़ी है कि Telegram पे सारा आपका practice हो जाएगा. So my objective was to get some of you starting to seeing questions. Now onwards, I will start discussing something else. How to attempt question. आज मैंने एक question डाला था. It was a very interesting question. And I got couple of responses and all of them were getting the question wrong. The question was that Himalayas have the following features. The feature was deep gorges. The feature was a U-turn in the river valleys. The feature was parallel ranges. And the feature was steep slopes and landslides. The question was, which of the above is an evidence of Himalayas as young fold mountains? Okay. All of them missed out this sentence. पहला वाला पढ़ा, ये चारों हिमालय से मिलता है, मार्क करके आगे 4. 1, 2, 3, 4 is right. Okay. So, which of the following are evidences of young fold mountains? The choice है, वो choice, okay, not all of them fit into. So I will discuss these type of questions. Okay. Ideally, this is an evidence. एक evidence है. What about these two? Evidence है या नहीं है? Okay. So, and if you look at the choices, you will feel that question is wrong. Actually, question is not the best choices given to you. But you must have a method in how are you solving these questions. एक choice था 1 and 2. एक choice था 3 and 4. One choice was, I think, 1, 3 and 4. Yeah, 1, 2 and 4. And one was 1, 2, 3, 4. Okay. So the idea is not to get the answer right. The idea is कि ऐसे question में सोचा कैसे जाता है. The common mistake is आप ये भूल के आप इसको पढ़ के मार्क कर रहे हो. So from now on, I will start discussing these type of tricky issues. I'll tell you what the answer should be. You go back and think once. Forget about the answers given by the booklets or the question banks. आप बताओ आप क्या मार्क करके आते. Of course, some of you have not done GS yet. ठीक है, you can leave it. Others, okay, I'll discuss these type of questions. So you can join the Telegram channel for this. And on that, I'll also announce whether we'll have the class or not. ठीक है, चलो, catch you guys either tomorrow or day after tomorrow.